On number 56, we are told that a large painting in the style of Rubens is 3 feet longer than it is wide. So the first thing you should do is sketch a diagram of this description. And when you do that, you want to give yourself space around it. If you've been following my recommendation to draw the diagram as you go, because you never know when you're going to add stuff to the outside of it. But we do know that it is 3 feet longer than it is wide, so we'll label this W and this W plus 3. And then we go on to read that if the wooden frame is 12 inches wide, now as soon as you notice a unit change, you should be careful here, because these measurements were given in feet, and then now we're given a measurement in inches. And luckily it's 12 inches, which means that we've just added a foot to the outside of this rectangle in every direction. That's a terrible straight line, or even a rough approximation of it. One more try. That's better. Okay, so then we have each of these is congruent at 1, and this is 1, and then this is 1. Alright, then we go on to read the rest of it, and the area of the picture and frame is 208 square feet. So that means our total area. Well, remember we're working from A equals LW here, and our area is 208 square feet. And then our length is W plus 3, but that's just the picture, so we have to add a foot on either side, so it's W plus 5. And then our width is W plus, the frame on either side would be W plus 2. So that's our equation, and obviously it's going to be quadratic, so we get 208 equals W squared plus 7W plus 10. And then we subtract 208 from each side, because anytime you're solving a quadratic, that's the first thing you should do, is get all your terms on one side, and you get W squared plus 7W minus 198. And then when you're solving a quadratic, your first attempt should be to factor it. So we're going to go ahead and set up our binomials with a W in the first spot of each, a plus and a minus, and we need a factor pair for 198 with a difference of 7. Well, if you start down your list, we have 2 and 99, 3 and 66, and then if 3 and 66 works, then 6 and 33 will. And obviously the first two, there was no way we were getting anywhere close to 7, so you can stop and check here. We're at 27, and then we can pull a 3 out of that 33 and put it over here with the 6, and we'd have 18 and 11, and we found our pair. So we're going to put the 18 with the plus, the 11 with the minus, and then our two solutions are W equals negative 18 and W equals 11. Well, in this application, because our domain restriction would be that W has to be positive for sure, then we know that our answer is 11, and the question was we need the dimensions of the painting. So the width is 11 feet, so it is 11 feet by, and since the length is 3 feet longer, 14 feet. So this is a pretty large painting. Then we look at number 58, in which we are given that the Welcome Home Apartment Rental Company has 1,600 units available, of which 800 are currently rented at $300 per month. A market survey indicates that each $5 decrease in monthly rent will result in 20 new leases. So the rent is $300 a month. the survey indicates that each $5 decrease will result in 20 new leases. All right, so we kind of jotted down the bare facts of the situation, and then we go to part A, which says, determine a function R of X that models the total rental income realized by Welcome Home, where X is the number of $5 decreases in monthly rent. Well, if you will look in your packet, and I'll flip back to make sure I'm telling you the right page number, I believe it's page 8, and it is. At the bottom half of page 8 has some like business terminology described there for you, and a couple of little equations that help you realize how to make problems like this a lot simpler. So this is a revenue equation that we're writing, and revenue is equal to price multiplied by the number sold. Okay, so if we can write an X expression that tells us what the price is and an X expression that tells us how many units we're going to rent, then we're in good shape here. We've got our equation. So this is R of X equals, and our price is currently $300, but we're looking at a $5 decrease, and we're going to use X as the number of decreases we're going to do, so it's going to be minus 5X. And then we're going to multiply that by the units we've rented. So we currently have, oh, and I left that out of our pertinent information at the top. There are 800 currently rented, and so we're going to start with an 800 there, and then for every decrease in the rent, we're supposed to gain 20 new leases. So we'll do plus 20x, because each decrease is going to bring us that many more. So that's the answer to part A. And then when you get to part B, sorry, I switched to eraser and forgot to switch back to pen. When you get to part B, it says find a graph of R of X for rent levels between $175 and $300. And that would happen at, if you do 300 minus no decreases, that would be the upper limit of your change. And then 25 decreases would take you to 175. So that translates to X coordinates of 0 and 25. So for your window viewing. And that just saves you a couple minutes in terms of translating all this into answers. And then when you graph it and get your zoom situated with the from X equals 0 to 25, this is the graph you should see. And then, of course, you'll use your tools on your calculator, either tracing if you have an Inspire, and or even with Inspire, you can do what you can do with the other calculators, where you use your calculate menu to find the maximum value, which is what actually part C is asking us to do. So when we trace or use whatever tool to locate our maximum, we get the coordinates here of 10, 2.5e plus 5. And just to make sure you're clear on what that means, that's 2.5 times 10 to the 5th, or move the decimal 5 places to the right. So what that tells us is that the maximum revenue, and I'm kind of jumping from part B to part C here. Part B was to obtain these graphs. And then part C is what rent will yield the maximum monthly rental income, which is where the tracing and finding that point comes in. So the maximum revenue is, and when you translate that scientific notation number, you get $250,000 per month. And that is when, let me erase this scratch over here, when rent is $250 a month. And on to number 62. If I can turn the page. The Sandusky Little League uses a baseball throwing machine to help train 10-year-old players to catch high pop-ups. It throws the baseball straight up with an initial velocity of 48 feet per second from a height of 3.5 feet. Well, when you read a problem like this, where obviously an object is projected into the air, that's when you want to look at vertical free fall motion, which is the equation on page 9 of your study guide. And this is the general form. And this will come up probably fairly frequently, depending on what you major in college. You'll see this again from here on out to the end of your formal education probably. So it is negative 1/2 gt squared plus v sub 0, which is initial velocity, times t, plus s sub 0, which is your initial position. And g here is the coefficient due to gravity, which if you're in customary measure, which we are here because it's in feet, we know that our g is 32. So the particular equation for this, since it specifies the height of the object, so this is our part A, find an equation that models the height of the ball t seconds after it's thrown. We're going to take the information we were given, which I just realized I have not yet recorded. So let me go back and catch that. An initial velocity, so that means my v sub 0 is going to be 48. And from a height of 3.5 feet means that my h sub 0, which is the s sub 0 in the generic form, is 3.5 feet. So our equation becomes negative 1/2 times 32 would be negative 16 t squared plus 48 t plus 3.5. And that's our equation. And then B says, what is the maximum height the ball will reach, and how many seconds does it take to get there? Now, we did the other one with technology, but I want to show you here how to do this one without using your technology. So we know that this is an upside down parabola because of our leading coefficient negative 16 and the fact that it is quadratic. So we know that this happens at the vertex. So to locate the vertex, I'm going to use x equals negative b over 2a, which for this problem is negative 48 over negative 32, which is positive 3/2. So that is, we know already that the maximum height occurs at 1.5, let me make that an at symbol, 1.5 seconds. So we already know when it happens. Now we are going to see how high it goes. And to do that, we could either plug that lovely little decimal or fraction back into our quadratic, but we're in the no calculator mode, just because that's what I want you to be here, because you can. Or we could complete the square, so that would be up to you. I'm going to go ahead and plug this in and show you that it's not horrific either way. So we're going to do h of 3 over 2 equals negative 16 times 3 over 2 squared plus 48 times 3 over 2 plus 3.5. Oops. My 3 didn't want to make a 3 there. Alright, so let me switch colors and we're going to do some canceling here. Because now, if I square the 2 on the bottom of the first term here, then this would become a 4, but I'm going to cancel that 4 and with the 16 and make the 16 turn into a 4. So then I'm left with 4 times 3 squared, negative of course. So I get negative 4 times 9, and then cancel the 2 off the bottom here and make that a 24, plus 72, 24 times 3, plus 3.5. And then negative 4 times 9 is negative 30, no, yeah, sorry, negative 36 plus 72 is positive 36. I knew I had a positive 36 in my head and couldn't figure out where it was coming from because it's late and I'm tired. So this is 36 plus 3.5, which gives us 39.5 feet. So we would translate this into a final statement of the ball reaches a maximum height of 39.5 feet 1.5 seconds after the ball is thrown. And that is the end of this video and your 2.1 examples.